Okay, hello. This is the second tutorial session of General Chemistry 1. And so from now on, until the first midterm exam, I'll receive your problems via email. So if you have any problems about the textbook's homework and the selected problem inside of the textbook, you can email me. And if the problem you ask me is kind of easy and should be easily solved and explained by email, then I will just simply reply you. But if your problem is kind of need to be explained by orally, and I think that many people might have the same problem as you, then I will record a video and upload it to the video YouTube playlist. So the second tutorial session of this course will not be updated by any schedule. So basically, if somebody asks me and I have time and I record the video and I explain about this, I will upload it to YouTube immediately. 好，用中文简单讲一次，就是到第二次期中考之前，那个你们问我的任何问题，只要我觉得可以轻松的解决的话，我就是那个 email 随便不是随便 email 轻松的就给你们做一些完整的答复，尽量的。那如果说我觉得你问的问题很不错，那很重要，那可能大家也会有类似的问题的话，那我就会录个影片，然后接下来讲。那个不会定期的去做更新，就是一有问题我就会立刻更新。Okay, so for for this video, as example, students asked me about problem about precipitation, and he said that the textbook's given table about precipitate or dissolve is not complete enough. That when he is doing the question inside of the textbook, it is kind of many exception in contrast to the textbook's table。那就是说，那同学觉得说，他在写题集的时候呢，有一些 table 举的这个沉淀的例子，好像在那个习题中都没有出现，所以他就请我来稍微解释一下这件事情。So, about the precipitate scenario, you should memorize this table. Then if you do not memorize this table, then you will not be able to solve the problem inside of the textbook, many of the textbook. So let me explain this scenario very quickly. So basically, it has three big column, and which is three categories. One is dissolve, always dissolve, and the second is usually dissolve, and the third is usually will not dissolve. So basically, usually dissolve means seldom precipitate， 那就是大部分会溶解的话，就是少数的时候会沉淀。And if it usually will not dissolve, and the contrary, the opposite direction of usually will not dissolve is dissolve. So if it usually will not dissolve, then a few scenario it will dissolve inside the water. So let's take a look quickly. So basically, if you see anything meets the anion like NO3 minus or acetate ion, this is nitrate ion and acetate ion. Anything meets these two kinds of anion, it will dissolve in water no matter what it is. And any anion meets the cation, like the first family, which is sodium, potassium, cesium, like that, rubidium, like that, or the ammonium ion inside of one in a liquid solution, it will always dissolve. And the part of usually dissolve is over here: chlorine, bromine, iodine, sulfate ion, and chromium acid ion. Chromium acid, yeah, chrominate ion. This is the kind of anion that usually when they occurs the cation, they will dissolve inside the water. But these are the exceptions, so you have to memorize this over here. And this is the anion that usually will not dissolve. So basically, many kinds of cation meets this anion will precipitate inside water. So basically, there will be a solid inside of water. just put on. If you mix these two together, it will go to the bottom of the water and has a form of solid. So basically, this is the chart that you have to memorize in order to solve the problem. And later on, I will use some examples to teach you about this. And those examples are also one student's messages to me, and I'll explain now. So in problem 15, differentiate between what happens when the following are dissolved in water. So part A and part D is actually similar. So polar solute versus non-polar solute when it dissolves in water. So a quick thoughts about this problem is that when a polyid compound meets a polyid compound, and it can be mixed together, which means usually is liquid to liquid or liquid to solid. If it's you have so basically you have to use some method to make them mixed together. So when the polar liquid compound is a polar liquid compound, it will mix together and dissolve with each other. And polar liquid compound can dissolve polar solid compound as well. So basically, if two things are polar compound, they can dissolve with each other. So when polar solute go into water, put it in water, it will dissolve, and non-polar solute will not. Okay, so in part D, okay, nitric acid is very strong acid. So basically, you know that strong acid put inside water, then basically it will has a lot of hydrogen ion inside of the cup of mixture, which makes it very acidic. 就会让它很酸, make it very acidic. Okay, so basically it will dissolve in water, and this is carbon monoxide, and it is easily to see that it is a polar compound because the oxygen atoms will take away partially the carbon atoms electron, so which makes this compound a little bit like unbalanced, because this part in oxygen will be more minus because it contains more electron inside of this, and this carbon will be partially positive, so it has a polarity. So the polar compound will dissolve in water. So carbon monoxide can dissolve in water. So in part B and part C, potassium fluoride, let's see in the side this chart. Okay, we see over here, potassium is first A family. So basically, when you see first A family in the cation, no matter what anion does it meet, it will always dissolve inside the water. So the potassium fluoride can dissolve in water. This is for sure. And this is glucose, 葡萄糖. Glucose, as you know from common sense, this is sugar. So basically, I think it's common sense that it can dissolve in water. Okay, in part C, it's kind of important, but still basic. So like, okay, rubidium fluoride, let's see over here. You see the key to this problem is fluoride. So over here, when you see fluoride as anion, what can make it precipitate and not dissolve is silver, lead, dimercury, and Cu1 and Tl1. And this is what the cation can make it precipitate. And most of the cation can make it dissolve inside of water. 所以大部分的东西跟氯键在一起，然后结在一起，这个 compound 它融到水里面，它是会解离的。那只是少部分会那个析出的部分会作为这个沉淀在里面。So rubidium chloride will dissolve in water, and there will be no precipitate inside of the water. But over here, silver chloride over here, when an ion of chloride ion meets silver ion over here, they meet together and they will precipitate. Okay, so basically, this kind of problem will test you about how familiar are you regarding this chart. Okay, so next one. Okay, so problem 39, write the balanced molecular, complete, and net ionic equation for the reaction, if any, that occurs when aqueous solution of the following are mixed. So basically over here, he said all of these are aqueous solution. That means all of the compound over here can be dissolved in water. So when you're thinking about this kind of problems, it means that when you see in each section, first you have to watch, you have to see what are these compound and what's anion and cation will it generate inside of this cup of water. So, and then you have to write down the following answer that the question wants you to write down. So it wants you to balance the molecular, complete, and net ionic equation. So basically, the molecular equations is just asking, is there any exchange happens inside of this cup of mixture? So and the complete is means that okay, if there has anything happens, you have to separate what separate those who can dissolve in water and tell me what has precipitate with each other, which 所以就是在这个 complete 的部分，就是你要先把所有的东西全部分开。如果说可以分开的话，那最后再跟我说有没有东西是连在一起，然后析出。Okay, so complete equation is just write down all of the ion, the cation together, and if there is any precipitate happen, you have to write it down. And the net ionic equation is very simple. The net ionic equation is just tell me what happens because we already know that there will be some cations and anions in this cup of mixture, and if nothing precipitate has happened, then you don't need to have you don't need to write any reaction because nothing happens. But when just one precipitate happens, like in part A, and then maybe there is a lot of cation and there is a lot of anion, and one pair just happens to precipitate, then you only need to write that pair of reaction. 那你就只需要写那一对的这个那对反应。Okay, and this question's answer is I taken from another textbook, so it is not this edition of textbook that I taken from. So I do not have this edition of solution manual. So if you need anything else, you should do it by yourself because I already sent a copy to you. So, okay, so let's explain about this. Ammonium sulfate and barium nitrate. So over here, ammonium sulfate and barium nitrate is over here. And first, you see the sulfate anion will precipitate when it occurs to 3. But we see here the ammonium ion can dissolve in water when whatever anion it emits. So this will dissolve. And barium nitrate over here, the nitrate anion can dissolve in water with any cation it met. So basically, in the complete equation, we can see over here that all of the cation and anion can dissolve in water. And secondarily, we want to see what is there any precipitation can happen. So over here, we saw sulfate ion over here and barium ion over here. So we know from the chart over here, when sulfate ion occurs, barium ion over here, Ba over here, the precipitation will happen, which means they will form a solid and sink underneath the cup of mixture. So over here, the barium sulfate will happens over here. Okay, so basically, the barium sulfate will come out over here. And the ammonium ammonium nitrate will keep as the same because some exchange has happened. So the complete ion is the complete reaction. You cannot write down anything about an ion or cation. So you can just take a look over here. And the baryon ion, so about the net ionic equation is just stated, just write down what anion and cation has having a reaction inside of this cup of mixture. So basically, it is just written like this. So in a B part, C part, D part, E part, I think you can all just take this chart as reference, then you will be very easily to solve this problem and understand about this. Okay, so let's move on. So in the 40th question, how would you separate the following ions in aqueous solution by selective precipitation? So selective precipitation is basically one method to do the separation. So I think this will be easy when you memorize this chart very thoroughly inside of your mind. So basically, in part A, there are 3 cations over here. And if you want to do selective precipitation, it means maybe you want to just precipitate one ion, one cation at once. So these are the examples I think about and I written down over here. So basically over here, Ag, Bn, A, and Cr. So let's take a look over here. You want to make this, you want to make one of this precipitate, but the other 2 shouldn't precipitate. So the first thing over here, you can think of something like, you can just take a look over here. So basically, when the sulfate ion meets Sr, Ba, and Pb over here, it will precipitate. So in this part, Ba will precipitate with the sulfate ion over here and left silver and chromium over here. And next on, we know that the chlorine acid, not chlorine acid, the chloride ion can precipitate with the silver ion. So next on, this will happen. Okay, I think I have explained enough over here. And then the rest of all, you can just watch it by, you can think it and take a reference by my hand notes. So that's all for 15, 39, and 40. So if you do have any question later on, you can just ask me. Thank you.